what's it like to design a trip to orbit? You have to know where the satellite's going, how much it weighs, and here's how we do it.
And lift off.
We start by figuring out which of our rockets is right for the job. This is determined by the amount of thrust needed to lift the spacecraft to their desired orbit. A mission to Pluto may have a very light spacecraft, but it needs to go incredibly fast, so it needs a very powerful rocket. A military communications satellite may not need the speed of a planetary mission, but it too needs a powerful rocket because of the weight of the spacecraft. Because we can add solid rocket motors, we're able to really tailor the rocket to specific customer requirements. Because of our launch system capability, we can also handle unique requirements such as for nuclear spacecraft or crewed missions. We decide how many burns and on-orbit coasts are necessary, as well as the launch times and durations to ensure the payload has a precise injection. A good way of looking at it is to think of the mission in reverse. Based on the destination, we work backwards to identify exactly when we need to launch. With this information, we create a trajectory to simulate the mission and allow other groups to analyze the aerodynamics, controls, guidance, thermal, and structural load environment.
With the basic trajectory design, we begin creating the software parameters that will guide the rocket to its exact destination. Our customers give us a target, and through our guidance design, we ensure we're going to get them right where they need to be. During this process, we simulate over 200 performance and guidance variations. The winds, the thrust, the weight, and even the gyros and accelerometers that help guide the rocket can all have variations that affect the rocket's ability to hit the target. We take these dispersions into account to make sure the design we have meets all the requirements. Our mission design process is so precise that we achieve a bullseye insertion 100% of the time.
An important element in our mission design is our relationship with the eastern and western ranges. The ranges are where we launch the rockets, and they are responsible for the safety of people living around the launch sites. We provide the range teams with a lot of data, so they'll know where we expect to fly as well as where we could fly if there are strong winds or variations. We want to make sure they know exactly what we are able to do so they can perform their jobs. The ranges take the information we provide to create displays identifying destruct lines and, on day of launch, show the trajectory of the rocket compared to the data that we provided.
Most missions have specific requirements that dictate their launch site. However, with a bit of innovative thinking, our mission design team can create opportunities that make the best use of our nation's space launch resources. A great example of this is NASA's InSight mission to Mars. To date, all interplanetary missions have launched from Florida's eastern range because of the added performance from the Earth's rotation. But our Atlas V rocket has the performance to launch the mission from California's western range, where the launch pad is not as in demand. Out-of-the-box thinking like this enables us to maximize the opportunities for our customers to get their missions to orbit. The trajectory we designed for InSight will take it over the South Pole on its way to a hyperbolic escape from Earth towards Mars. As an added bonus, Atlas provides enough performance to add an auxiliary payload called Marco to the InSight mission. Marco will deploy 2 CubeSats on the same trajectory bound for Mars.
Innovative thinking can also be applied to the launch window. Our goal is to always launch the beginning of the window, but there are occasions when extra time is needed to work through weather or technical issues. As mission designers, we do everything we can to maximize the time we have each day to launch. Typically, rockets going to the International Space Station have very short or even instantaneous launch windows, which can result in a launch scrub if an anomaly occurs during the countdown. Using software to develop trajectories that adjust how the rocket flies, depending on the time we launch, provides ULA's OA4 cargo resupply mission with a 30-minute window to launch. Each of the trajectories steer differently to make sure we deliver the Cygnus spacecraft where it needs to be to rendezvous with the space station at precisely the right time.
And that's what it's like to design a trip to orbit.